In section 8.4, we'll be talking again about similar triangles and two important points of them. The first one is that if we have similar triangles, the corresponding sides of triangles are proportional. The second is that corresponding angles of triangles are congruent. We're going to take a look at a few examples that use these two elements in proofs and how we prove them and how we would use them. The first example, we have the diagram at the right, and we are given that YSTW is a parallelogram, and that SX is perpendicular to YW. SV is perpendicular to WT, and we're trying to prove that SX times YW equals SV times WT. Now, usually when you have multiplication, like you see in the proof, it usually leads from the mean extremes of proportional, where a cross multiplication was occurred. So let's look at where those segments are. We have SX and YW, and we have SV and WT. Now, what you'll kind of notice, although those aren't a part of, or give you a triangle in themselves, they're a part of it. We can see that YX, SX, SV, and VT. So we're going to try to get those two triangles similar. The first thing that we can do then is, because we have a parallelogram and we know the properties of parallelogram say that opposite angles are congruent, we'll say that angle Y is congruent to angle T. Based on the other information of the given statements, we have perpendicular lines which will establish right angles here and here. And since they're right angles, then they are congruent. And now, since we've established two angles congruent, that establishes that the triangles themselves will be similar based on angle. From there, we'll use the proportion property of similar triangles, and we'll make a proportion out of these. And we will say that SX over SV is congruent to SY over ST, because corresponding sides of similar triangles are proportional. And if we use the mean extremes theorem and multiply them, we'll see that SX times ST is equal to SV times SY. And if you look at that, that is very similar to our proof up there. SX times YW equals SV times WT. The differences obviously are here and here. So how are we going to change those? Look at where WT and YW are. They're in the full length of the sides of the parallelogram. Well, because they are parallelograms, we know that the opposite sides of the parallelogram are congruent. ST congruent to YW and SY congruent to WT. From there, we'll do a basic substitution to get our proof. We have one more quick proof using these 2 points. The first one, we're given that CB over EB is congruent to AB over BL, and we also know that CB is perpendicular to AL. Based on the definition of perpendicular, CB perpendicular to AL, we know that right angles are going to be formed, CBA and EBL. Since they're right angles, we know that they will be congruent. And since in the given, we know that CV over EB is congruent to AB over BL, we know that CB will be proportional to AB as well as EB proportional to BL, which means that the sides themselves are similar. So we can go ahead and we can say that triangle CBL is similar to triangle EBA versus side angles side similar. Therefore, once we get the triangles similar, we can then say the corresponding angles of the triangle are congruent because similar triangles have congruent angles.